Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we want to talk about this. There's like a master equation for how things move. It's called the equation of motion, and it's simply this. Now, this is in the x direction, so x final, or x2 if you will, equals x beginning plus the velocity times the time plus half times the acceleration times the time squared. This, by the way, could just as well be written in the y direction, but it could also be written in the x direction. So like a classic question that's often asked is, well, it's this. All right, we've got a runner who runs at a constant velocity of 8 meters per second and another who starts at rest and accelerates at 2 meters per second squared. They leave from the same location. When will they meet? This is like question A, if you will. And B, how far will they be when they meet? So let's think about this. We've got two runners. We've got runner A, who's moving at a constant velocity of v is 8.0 meters per second. By the way, when we say constant velocity, that also means that A equals 0, all right? And this is runner number 1, right? And number 2 is accelerating at just 2 meters per second squared, and his initial velocity, or v1, equals 0. This is v1 as well. And we do know A, and we're trying to solve for when they're going to meet. So what we really want to do is write the equation of motion for each individual, and then what we're going to do is we're going to set them equal to each other and solve for the time. So what have we got here? We've got x2, so they're going to meet when x2 equals the same thing. So let's write the equation for runner number 1. So number 1, we would say x2 equals 0 plus 8t. That's it, actually, because that A, you can say plus 0 times 1/2 times t squared, but 0, because there is no acceleration for runner 1, ball game, it's even. For runner number 2, we would say x2 equals 0. They're both starting in the same place. This could change, by the way. Maybe this person starts ahead of this person or whatever, plus 0t, because they start with no, because they're starting, and then they start plus 1/2 times 2 times t squared, which, when you simplify this, of course, is just t squared, because 2 times 1/2 is 1, so it's just x2 equals t squared. So at what point are they going to meet? It is when x2 equals x2, if you will. They meet at the same point. So I can say 8t, that's his equation, equals t squared. So I can cancel off a t algebraically now to solve this problem. This t cancels this t, so I get 8 equals to t. So t is 8. So they're going to meet, when will they meet? They will meet at 8 seconds. Because the first guy is moving fast, right? He's moving fast, and this guy's slowly catching up. Okay, how far will they travel when they meet? Now, how far, it doesn't matter which equation you put it in. You're just going to put 8 into here. 8 times 8 is 64. So they're going to meet, so I can just plug it into this, and I would say that it equals to 64 meters. By the way, if you plugged it into this equation, which was t squared, 8 squared is 64, right? So you'd get the same answer when you plug it in. So they meet from the same location. So when you're doing these equations of motion, you're just saying this person is moving. And we're sort of focused right now, at least in my class, on moving in the x direction and back. We could have a negative velocity too, or whatever. Another interesting question that could be asked, and I won't work it all out, but I just want to talk about it, is you could have a car that's moving in this direction and a car that's moving in this direction, and then you'd have to say, at what point will they crash into each other, right? If you have the equation of motion, this one would obviously start with a negative velocity, and this would have a positive velocity, but then you have to set them equal to each other. The trick on this one, by the way, is to try to figure out, you're going to define this as x equal to, let's say that we know their distance, that this is, x equal to 0, and this is 10 meters apart, right? So when you do your x1 and your x2, your second guy, for playing this game, his x2 is 10, and we're trying to figure out, no, his x1, pardon me, his x1 is 10, where this guy's x1 is 0, right? If we're dealing with, this is guy 1, this is number 1, and this one is number 2. And then you can set the change, and they're all going to make the same, probably set the x2 equal to each other. You do the equation, and you can find out at which point the two collide. So it's going to be the same kind of idea, but oftentimes you don't just like use the equation once and solve it. You're going to use it twice, set things equal to each other, that kind of a thing, to see where the intersection of the things happen. Houston, we don't have a problem.